Hi students, welcome back to NEET Chemistry 360 series. In this series, we have been exploring the solution for previous year NEET Chemistry exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. So this is the problem from NEET 2023 as per this question. So here you see there are 7 compound structures or species structures are given. So here we are asked to find out the number of compounds or species which obey the Huckel's rule. Before moving to the solution, let's talk about what is mean Huckel's rule. So Huckel's rule state that there are 4 types of rules are known if any compounds or molecules or ions that obeys the Huckel's rule, those compounds are considered as aromatic compounds. So let's see one by one all the rules. The first rule states that cyclic, the aromatic compounds are always cyclic. So here the molecule must have a cyclic or a ring structure. So second rule states that planar, the ring must be essentially planar, since allowing for effective overlap of p orbitals. So third rule states that conjugation, the ring must have a continuous system of overlapping p orbitals, usually involving alternating single and multiple bonds. So fourth rule is 4n plus 2 pi electrons rule. The cyclic conjugated system must contain 4n plus 2 pi electrons, where n is a non-negative integer such as 0, 1 or 2, etc. Let's analyze each of the given compounds step by steps by using Huckel's rule. So the first compound structure is here. The compound name is naphthalene. So first we should see whether this compound is cyclic or not. Yes, it is a ring. So second we should see this compound is either planar or not. For a conjugated system of this size to effectively overlap, it generally adopts a planar or near planar geometry. Therefore, this compound is planar. So next we should see how many delocalized pi electrons are present in this compound. So here you see this compound has 5 double bonds. So which means that each double bond contribute 2 pi electron. Therefore, total there are 10 delocalized pi electrons are present in this system. So let's moving to the 4n plus 2 pi electrons rule. So here 4n plus 2 equal to 10 pi electrons present in the system. Therefore 4n equal to 10 minus 2. When you move plus 2 to this side, which get negative, so 10 minus 2, then followed by when you work it out, which gives as n equal to 2. So which means that it obeys the Huckel's 4n plus 2 pi electrons rule. So let's moving to the our second compound, so which is cyclopentadienyl anion. So this compound is cyclic compound, and this compound adopts a planar structure. So it has a 2 pi bonds, which means that each pi bond contribute 2 pi electrons. Therefore, total 4 pi electrons from these 2 double bonds. So apart from that, here one negative charge also present here. So which contribute 2 electron. Therefore, total 6 delocalized pi electrons present in this compound. So let's moving to the 4n plus 2 pi electron rule. So 4n plus 2 equal to 6 pi electrons present in the system. So when you work it out, which gives as n equal to 1, it obeys the Huckel's 4n plus 2 pi electrons rule. So next moving on, our third compound, which is cyclobutadiene. So this compound is cyclic compound. Again, this compound adopts a planar conformation, and here there are 2 double bonds are present. Therefore, total 4 delocalized pi electrons are present in this compound. Next, moving to the Huckel's rule, 4n plus 2 pi electron rule. So 4n plus 2 equal to 4. So 4n equal to 4 minus 2, then n equal to 2 by 4, which gives us n equal to 0.5, which means that it violates the Huckel's 4n plus 2 pi electron rule. So next moving to the fourth compound, so which is cyclopropenyl anion. So this compound, cyclic compound, this compound also adopts a planar structure and it has 4 delocalized pi electrons. So double bond contributes 2 pi electron and this negative charge contribute 2 pi electrons. Therefore total 4 delocalized pi electrons. So next moving to the 4n plus 2 pi electron rule. So 4n plus 2 equal to 4 since it has 4 delocalized pi electrons. So now you move this plus 2 to this side which get now minus 2, 4n equal to 4 minus 2 which gives us n equal to 2 by 4 and finally n is 0.5. So it also violates the Huckel's 4n plus 2 pi electron rule. Next moving on, so this is the fifth compound, so which is cyclopropenyl carbocation. So first we should say this compound is cyclic or not. Yes, this is a cyclic compound. So next we should see this compound present in a planar structure or not. Yes, this compound present in the planar structure. So three-membered rings are inherently planar due to their geometry. So next we should see conjugation or not. So we have a double bond and one positive charge indicating a vacant p orbitals present in this carbon with a positive charge. So the vacant p orbital can participate in resonance with these pi electrons of the double bond. So creating a conjugated system. Therefore, it has two delocalized pi electrons. So next moving on, 4n plus 2 pi electrons rule. So we have 2 pi electrons from the double bond. So using Huckel's 4n plus 2 rule, which gives us n equal to 0, which means that this compound obeys the Huckel's 4n plus 2 pi electrons rule. Next moving on, our sixth compound. So this is interesting compound. So which is cyclooctatetraene. So this compound is cyclic compound. So next we should see either this compound is planar or not. So this compound contains 8-member ring system with alternating double and single bond is known to adopt a non-planar dub-shaped conformation. So which should avoid the angle strain and unfavorable interaction. So usually this compound adopts this type of dub-like conformation. Okay, next we should see either it has conjugated system or not. So definitely this compound doesn't have any conjugation. You just imagine if it were planar, it would have a fully conjugated system of pi electrons. However, due to its non-planar geometry, the p orbitals are not aligned for effective overlap. So therefore, and the conjugation is disturbed. So next moving on, 4n plus 2 pi electron rule. So here there are 4 pi bonds, which means that it contains 8 pi electrons. So 4n plus 2 equal to 8. So which gives us 4n equal to 8 minus 2, then n equal to 6 by 4, which gives us n equal to 1.5, which means that this compound violates the Huckel's 4n plus 2 pi electrons rule. So next moving on. So this is our final compound. So this compound name is anthracene. So here you can see that three ring system fused together. So this compound is cyclic compound as well as this compound adopts a planar structure. Apart from that, here we should see that how many double bonds are present in this compound. So there are 7 double bonds are present in this compound, which means that it has 14 delocalized pi electrons. So now you work it out. 4n plus 2 pi electron rule, 4n plus 2 equal to 14. Now 4n equal to 14 minus 2. So which gives us n equal to 3. It obeys the Huckel's 4n plus 2 pi electron rule. Okay, let's moving to our question. So as per our discussion, the compound 1 obeys the Huckel's rule, as well as compound 2 also obeys the Huckel's rule, and compound 5 also obeys the Huckel's rule, and finally compound 7 also obeys the Huckel's rule. So therefore, as per our discussion, among the four answers, the correct option for this question is option 1. So apart from that, here you should note that this compound 3 and compound 4, so these two compounds are obey the foreign pi electrons rule, which means that these two compounds are anti-aromatic compound. In case of this compound doesn't obey Huckel's rules as well as foreign pi electrons rule, therefore this compound is non-aromatic compound. So that's it for today's problem. I hope this video has helped you to understand this question. If you enjoyed this session, just give it a thumbs up and share it with your friends, and don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.